Well, welcome everybody. We're so excited to have you here for our Mountain States Concrete Pipe Academy webinar for today. We're this is great. I'm going to share my screen here, and we'll go ahead and get started. We're very excited to have Jeff Peck with Oldcastle Infrastructure presenting to us today. He was just telling us right before we started the broadcast, was just telling Heather and I that his favorite way of giving presentations is over webinar because he doesn't like to see people. Did I understand that correctly, Jeff?
Sounds right to me.
Yeah, exactly.
That's about right.
Degrees opposite. Thank you, Jason. Appreciate that.
Yeah, nothing like giving a presentation into like a void, a black box void. So we are excited to have Jeff with us today. He'll introduce himself a little bit, but before we do, let's talk a little bit about Mountain States Concrete Pipe Association, who we are, what we do. We do get this question quite a bit. What exactly is the Mountain States Concrete Pipe Association? Is it just you? What do you do? Who do you work for? Who do you work with? So the association itself is made up of two main member companies, Geneva Pipe and Precast. And with us, we have Heather. Heather, welcome. Good to have you here today.
Thank you. Glad to be here.
And then also, as I mentioned before, Oldcastle Infrastructure with Jeff Peck is here representing Oldcastle as well. So Jeff, thanks again for volunteering and offering to do this webinar. It's always nice to have people hear from the different member companies. Additionally, we've had presentations in the past from Ash Grove and Wholesome, who are our cement suppliers, who are also members of our association. And so we've had previous webinars about cement manufacturing and cement specifications and sustainability by Todd Laker from Wholesome and Heath Hall from Ash Grove. So it's always good to get some of these other member companies involved as well. It's been a lot of fun. So some of the things that we do is we're basically here as a resource to provide technical assistance for the reinforced concrete pipe and precast concrete industry. And we work very closely with engineers and specifiers, inspectors, and installers. And this presentation today is really good for those installers and inspectors, but it's also nice for engineers and specifiers to understand what we need to take into account when we're installing and inspecting concrete pipe or flexible pipe. So this is a real fun presentation today that'll help all of those groups. We do this by giving presentations at conferences. We've been doing these webinars, and we also do in-person lunch and learns and everything. So another thing that we do is we'll review and write specifications. If you have any specifications that you think would benefit from having us take a look at it, we'd be more than happy to do that. Please reach out to us and let us know. We also answer a lot of constructability and design questions. Sometimes, I'll get a lot of phone calls of, oh, we only have, like 12 inches of cover. What class of pipe? How would we do that? What would you recommend we include in the specifications in these low cover situations? And it's always nice to be able to provide that little information and suggestions on what to keep in mind. We want to make sure that our products are being installed correctly and to the best of the contractor's ability. And so we want to make sure they're doing that right. So we're here to answer those questions and help you. Now, some of the things that we're doing this year, we're really excited about this, the Academy. If you go to mountainstates.concretepipe.org/academy, obviously you can sign up for upcoming webinars. We have another one next month that Heather and I will be giving about engineering ethics and liability. This is one that we did about a year ago. It was a great webinar and a great presentation. So we thought, let's go ahead and do that again. So you have that to look forward to next month. Feel free to sign up for that. In addition, we are offering on our website, mountainstates.concretepipe.org/academy. You can get on and view any past webinars. We have those available. I'll have this webinar uploaded this afternoon so that if you missed it or you want to go review something again or look at something or have someone in your office view this, they will be able to do that this afternoon. So that's a really cool thing there. So before I turn the time over to Jeff, I wanted to give some fun facts about Jeff. I like to do this with all of our presenters and tell you fun facts. The fun fact that I have about Jeff is that he is the closest that I've ever come in person to the real Ron Swanson. He embodies a lot of the values that one of my personal heroes, Ron Swanson, has. And so I would say if you've ever spent any time talking to Jeff, he has a lot of views to Ron Swanson, including and especially his love of bacon and breakfast foods. So
I was going to ask you what those talents and traits were that you see in common there, Jason.
He loves his liberty, he loves his guns, and he loves breakfast foods. So that would be what I think is in common. Not so much the mustache. You got a little work to do there on that mustache growing there, Jeff.
But it won't be nearly that thick, I can tell you that.
I've actually been in a restaurant where it was almost played out word for word in the scene from Parks and Rec where Ron Swanson says, "Bring me all the eggs and bacon you have." Stop. What you heard was, "I want a lot of eggs and bacon." What I said was, "Bring me all the eggs and bacon you have." I've actually witnessed Jeff do that at a restaurant. So
Sounds about right.
yeah, loves his egg and bacon. So I'm gonna go ahead and turn the time then over to Jeff. I'm gonna throw this over to Jeff again. Thank you for doing this presentation, Jeff. It's always fun to have other people than me and getting to do a presentation. So
Okay, so let's see if we can get this sharing right. Look
looks
right.
good to me.
There it is. What do you know?
Right to me.
We got through it. Sounds great. And I really appreciate everybody coming out today. Those of you that are here, appreciate your attendance and your interest in this topic. It's a topic that obviously you saw that Jason gave at least a year ago, but with the amount of people that we have revolving through, the engineering community, the city community, inspectors, it's always good to get a refresher on most of these topics. And I'm just, it's an honor for me to be able to present with you today. So thank you very much. My name is Jeff Peck. I attended University of Utah and Weber State. We'll leave BYU out of the conversation. We'll talk about that later. Graduated from ITT, started with Amcor. There may be some of you, I don't know who's on here, so there may be some of you old enough to remember Amcor. Began in our engineering department, moved on through inside sales and things like that. Actually got the opportunity to manage our corrugated steel pipe plant for 9 years. That was down in North Salt Lake. Many of you didn't know that we had that, but so I've got quite a bit of experience with corrugated metal. And then we bought W.R. White back in 2000, and I managed that, helped manage the distribution side of that, where we sold HDPE, PVCs, ductile iron, hydrants, fittings, all the waterworks side. So I've got quite a bit of experience with those products as well, and have been regional sales manager for Oldcastle Infrastructure in the Rocky Mountain region north for the last 13 years. So that's just a little bit about me. And I guess I obviously missed the references to Ron Swanson, or I would have put some of my other, I guess, bona fides there to be equal to the task there. Here at Oldcastle, and probably with everybody that's on the phone, you're generally starting your day or starting a job site visit with a safety moment. So obviously we want to start with that. Part of today's message is definitely make sure you wear your PPE because it's very critical to everything we do. Helps stop situations like this. So, if I knew Jason would appreciate this one. Hopefully none of his kids on his baseball teams have had this experience. So always be wearing your PPE, always be safe. We also want to stress and emphasize, if you see something, say something. And I really like this guy. It takes a minute to look at this picture. It looks like almost like he's throwing that bat out of the stands. He's actually catching that bat being thrown off the field. I really like this guy. He really stepped up and did more than see something, say something. It would have been funny because you can see that there's about 50 people around him saying something, and I can just imagine what they're saying. This guy actually stepped up and actually did something about it. This guy here with sunglasses, he tried. We'll give him the honorable mention for trying to do something. And then also, make sure that, especially in your offices, most of us here are working offices. I had an experience last week. The FedEx guy came in and dropped some packages off, and for some reason our drop-off package spot is in a hallway right in front of the front desk. So as you walk down that hall, if you're looking at your phone or not paying attention, you're going to trip over them. So obviously we want to make sure that we analyze and take care of all trip hazards so that we don't have any hardships there, and we keep our people safe. So appreciate everybody thinking about safety today, thinking safety first. So we're going to talk about post-installation today, post-installation inspection. We're going to really focus on 3 different aspects. Pipe installation, installation of rigid and flexible pipes. They are different. They need to be installed differently. And that is where we lend into the inspection, whether it be during installation or post-installation inspection. Has a lot to do with how these different pipe types need to be installed. Then we're going to talk a little bit about some of the modes that some of the things that we should be looking for during inspection, and especially in post-inspection, that of cracking and deflection and a few other aspects that you can run into as an inspector. And then some types and forms of inspection that are available to the pipe market to make sure that we're getting these pipes put in correctly. We're first going to step into that pipe types and installation. A pipe needs to perform two functions. And the first one is it has to be a conduit. It has to be a method or not a structure, but it has to be a conveyance of water. It has to be able to line and convey water like a liner. And it also has to provide a structure to maintain that conduit shape and form so that it performs the way that it was designed to move that water. You can imagine if we just put a plastic sock in the ground, that would be a great conduit, but that wouldn't exactly give it structure and wouldn't be able to withhold and withstand the soil loads and the live and dead loads that are being influenced on that pipe. So we have to do two things as a pipe: provide a conduit and a structure. When we look at
let's go ahead and before you jump into this, let's do a poll question real fast.
Let's do
that one. This is kind of a review from our installation class that we did a few months ago. So let's see how many people attended that and saw that. I'm going to launch this first poll. I've got 2 poll questions we're going to do, and we're going to do them quickly. The first one is regarding structural pipe zone. We talked about how important the structural pipe zone is there, and we have to have a structure. So what is that for reinforced concrete pipe? Is it the pipe only, the bedding pipe and compacted material, the spring line, or bedding pipe and compacted material 1 foot above the pipe? Go ahead and choose now. We'll let you vote. If you're having trouble voting and it won't let you click on one, minimize or maximize your screen, change the screen size. Sometimes that, depending on the browser, it'll have some issues there. Looks like a little over half have voted, so we'll give it about 15, 20 more seconds here.
This is where I'm supposed to do the Jeopardy tones.
Oh, would you mind? Boy, that would be so nice.
Do. That's about all I know. I don't know the rest. And I don't know the words. I apologize.
I think we could probably find it on our phone, right?
I would think so.
Jeff, you don't know the Jeopardy tone?
Maybe for the next one,
Yes, I know the Jeopardy song, but I'm tired of singing it because I'm embarrassed of being recorded. So I'll just back down.
Heather's voice is much lovelier than both of ours. Maybe she could do it. All right,
Heather,
we're going to go ahead and close this, and I'm going to share the results here. It looks like over half said the bedding pipe and compacted material to spring line. About 30% said bedding pipe and compacted material to 1 foot above pipe. So, Jeff, for structural pipe zone for RCP, which is the correct answer?
Up to spring line.
Up to spring line. Yes, that is correct. Okay, now let me launch the next one. Let's because we're reviewing, we're talking both types of pipe, and we have to make sure we're getting these right. What about for flexible pipe? So that's for your corrugated metal or your plastic pipes. What is your structural pipe zone for flexible? Is it the pipe only, bedding pipe, compacted material to spring line, or bedding pipe and compacted material 1 foot above the pipe? So we'll give you a few seconds here to do that one. All right, looks like we're about 2/3 of the way through. We'll give it about 10 more seconds. All righty. So 5 more seconds. And we'll close it out. And let me share that one. Okay, so it looks like 86%, wow, overwhelming majority said bedding, pipe, and compacted material 1 foot above the pipe. And then a couple said bedding and pipe or bedding pipe and compacted material to spring line. Jeff, you were the you mentioned you worked in the corrugated metal industry for a hot minute there for
a hot 9 minutes.
Yeah. So what's the answer here for flexible pipe? Corrugated metal, plastic, thermoplastic pipes. What is the structural pipe zone for flexible pipe?
The phone a friend worked out great. It is a 1 foot over the pipe compacted area.
Minimum, typically, right? That's typically your minimum. Yeah. So depending on the diameter pipe, depending on it, sometimes it might be a little more, but that's pretty typical. Okay. Well, perfect. Excellent. I will turn the time back over to you then, my friend.
All right. Sounds great. And I guess at this point, some folks on the call may or may not understand what the difference is between a rigid and a flexible. A rigid pipe would be a concrete pipe. Flexible pipes are the HDPEs, PVCs, fiber reinforced, ductile and cast iron are actually classified also as flexible pipes. So those are the differentiations there between those two pipe types. So we move on and we talk about installing flexible pipe. We come into this situation where we find that some specifications want to treat them the same and allow them to be installed the same. And by specifications, both of them have very different installation techniques and requirements. So those definitely need to be studied and implemented into your specification for whichever city or entity you represent. Flexible pipes are flexible by nature. The loading will come down on top of the pipe. That the natural forces of the bedding will push back with that same force, and the flexible pipe will want to bow and to expand out and deflect. And it's up to the soil on the sides of the pipe to resist that deflection force that's coming out. So it's very critical that we layer, do our compacted layers and compact them to the required amount by specification, so that when that deflective force starts to push that pipe out, that side soil pushes back with enough force to maintain the round or the integrity of the pipe that's been installed. So that backfill around the pipe is very critical. When we look at rigid pipe, the structure comes on the truck. So when those forces are pushing down on the pipe, that pipe is transferring that force back down into the bedding material. And really, you need to make sure that you're compacting along the sides of a rigid pipe to make sure that soil maintains its height, so that you don't end up with any dips in your road. So you do need to make sure that they compact enough to maintain structural integrity of the road or whatever's on top of it. But it doesn't need the compacted layers that flexible pipe do. So when we compare rigid to flexible pipes, when we look at a feature, the rigid pipe is a structure. As we talked about before, we need to be a conduit and a structure. And a flexible pipe is really just a line or a conduit and requires soil to create the structure around it. The pipe zone, as we talked about earlier in our poll, rigid pipe can be backfilled and compacted up the ridge line. Flexible pipe needs to be at least compacted in layers, even lifted layers, evenly balanced on the two sides of the pipe up to at least 12 inches over the top of the pipe. Lift thickness really is not specified either by ASTM or UDOT. There probably are different specifications. There's probably people on the phone today that may have some specifications for a rigid pipe installation here that would be specific to their city or whoever they're representing. Flexible under their specifications have to be in 4 to 6 inch uncompacted lifts and then compacted, and that needs to happen evenly on both sides of the pipe as they come out. The structure for a rigid pipe is built in the plant. We actually build the structure and put it on a truck and deliver it to your job site. For flexible pipe, that structure needs to be built in the field, in the trench with the soils. And structural design for rigid pipe is actually taken care of in the plant. And it's either by specification or by the engineer at the plant. So we take, those people that provide rigid pipe take the responsibility of creating that structural design. And when you deal with a flexible pipe, by their specifications, typically that design, that structural design has to be performed by the engineer of record or the project engineer that's designing the project. So that's installation. We'll move on to some of the modes that you're going to find as you install pipe, both rigid and flexible. Things that we need to know are that concrete will crack. It's very common. I don't think that's a surprise to anybody on the call today. Whether you own a driveway or you've seen concrete pipe, you will get cracks in concrete, and flexible pipes will deflect, and that's what we've been talking about. We'll talk about a few of those modes.
Before we talk about what's acceptable, why don't we quiz them, Jeff, and see if they know.
Quiz them.
Let's quiz them. Let's see how much people remember from last year when we did this presentation. So the first question is, Per ASTM C76, which is our manufacturing spec that specifies what cracks are acceptable, crack width, what is an acceptable crack width? Is it 0.001 inch, 0.01 inch, 0.1 inch, or 1 inch? Go ahead and vote now. What is acceptable? Meaning it doesn't require any additional work or doesn't require repair. All righty. Looks like we've got everybody voted who wants to. All right. Should we, let's share the results here. We had, some said 0.001 inch. Some said 66%, 2/3 said 0.01 inch. 24% said 0.1 inch, and nobody said 1 inch. That's probably good. A 1 inch crack on a 15-inch pipe is probably a little bit big. So, so should we put Heather on the spot and see if Heather wants to answer and let them know which group was correct?
I would have said 1 inch. I mean, hilarious, but
measure with the thumb.
0.01 inch is your accurate answer, and it looks like most people knew that.
Well, and to be fair, if you said 0.001 inch, that is also true. That is acceptable, because that is less than the 0.01 inch. So that's 10% of you that you took the easy way out and said, yeah, that one, we know that one's also acceptable. So yes, 0.01 inch, that is correct. All right. Last one here, or the next one, not the last one, but the next one. Let's talk acceptable deflection per APWA and UDOT specs. Deflection in plastic pipes less than blank is acceptable. Fill in the blank. Is it 2.5%, 3%, 5%, or 7.5%? What is acceptable? Again, meaning that you don't need any additional work or any engineering letter. What is, if it's less than this, it is acceptable amount of deflection. Give you about half of you have voted here.
I think either of these guys have done this before. They're, really
Yeah.
nice. So good answers today.
Great answers today. Great answers. This one's interesting. I think everybody used the cop out on this one here. So far, let's I'm going to share this here. Everybody is correct. Everybody is correct in this one. Plastic pipe for like HDPE, polypropylene, the way it's written in APWA and UDOT is anything under 5% is acceptable. So theoretically speaking, 3% and 2.5% are also correct, but anything under 5%, anything over per APWA, anything over 5% is not acceptable. It's a remove and replace. In UDOT, between 5 and 7.5, you need to have a letter from an engineer. So you need to do a structural analysis and review it, make sure it's acceptable. Anything over 7.5 in UDOT is not acceptable. But yes, anything less than 5% is acceptable. So technically speaking, 3 and 2.5% would also be correct. So well done.
All right, Jeff, for everybody.
Yes,
we need to be doing this for fabulous cash and/or prizes.
Oh, we
should.
We have an
opportunity coming up. We'll give some cash away to some lucky participant. Okay, so what is acceptable? Well, let's start in on concrete, cracks in concrete pipe. And Jason just kind of went through that, so we'll roll through this fairly quickly. According to ASTM C76 for concrete pipe, an O100 inch crack in width, greater than 12 inches long, 1/4 inch deep. If you can take an O100's feeler gauge or like your old spark plug gauge and put that in, if it can go down, if it can go down 1/4 inch and it's greater than 12 inches long, then we have what we would specify as an O100's crack. Anything greater than that, then we'll talk about that here in a bit. But that's our O100's crack definition. UDOT and APWA refer to these as hairline cracks, and they ask that you evaluate cracks anything greater than an O100's crack. So what is an O100's crack? Well, Randy Wallen went out, and there's probably some of you in the audience today that actually have Randy Wallen's business card. So hold on to that because it's a great crack gauge. It's probably what it's useful for now. He went out and looked at this pipe, and I don't know if you can see that crack. This is a very fine hairline crack in this pipe that really didn't meet that. We could not get a O100's gauge in there 1/4 inch. These are the kind of cracks that are acceptable by specification. These cracks aren't going to offer any problems for you down the road under normal conditions. But if you did have Randy Wallen's business card, you could use that as a crack gauge. I looked it up, and a cardstock business card is 016, so it's barely over a O100 crack feeler gauge. So there you go, Jason, little tidbit. That's what Randy's business card's good for now.
I know when I've shown this picture in the past, Jeff, there's that that you can see that little chip off of the
Yep,
off
over
the,
here.
the bell there. Yeah, so that, or the spigot end there, that is actually a pipe that was removed, because in the video when they saw it, the owner was nervous about that crack, and so when they pulled it out and looked at it, it turned out it was less than so that was actually damaged while they were removing this piece of pipe and putting in a new one, and that, then when they pulled it out and they measured it, they couldn't even get a feeler gauge in there. So be aware of that when you look at these videos, that sometimes it may look really big if they're, depending on what kind of lens they're using on the crack videos, but they pulled it out and realized, wow, that's that doesn't even, that's not even close to a 0.01 inch.
I want people to remember this, because we're going to talk about this more here in just a bit, but please remember that when you're looking at this crack. We're gonna kind of touch on that here in a bit. So you're going to ask yourself, how big is an O100 inch? How big is that? Well, if you reach down in your pocket, if you still have coins, which, you know, in this environment, we may or may not have coins in our pocket, but if you have a dime in your pocket, that dime is about 0.05 thick. So you can just imagine, you know, pounding that dime down to 20% of its thickness. That's your gauge. So you can kind of get a feel for that. And for those of you that are and I apologize for any of you in the audience that are one of these that I'm going to slaughter this, but the numismatist, you say it, Jason.
It would be, boy, I want to make sure I don't get it wrong either. What was it? The numismatist is a coin collector?
Yes, coin collector. So those of you that are coin collectors out there, if you wanted a reference as to what the other coin thicknesses are, there you go. So if you're really looking at an you know, an 0.05 inch crack, which we'll talk a little bit more about, that dime is going to be a pretty good representation of that. As I mentioned before, we have fabulous cash and/or prizes that have been yet to be determined. It is time for our daily double, and Jason is going to pick a audience member to participate, and it will be on this person's obligation to decide how much money they're going to put on the daily double bet. And the topic is, what is the thickness of this coin that I'm about to show you? So
okay,
Jason,
so
who are we going to pick on?
We've never done this before, but we're going to see how this goes. We're going to see if I can do this. It says that I can unmute somebody, so I'm going to choose someone from our attendance pool, and I'm going to choose my friend Dexter. Dexter, if you're there, I'm going to unmute you, and now you can unmute yourself now, and maybe we can hear you. You get to answer the daily double question. If you can unmute yourself, let's see if this works. And maybe he's having problems there. If he can't do that, we could try someone else. He just got in a question. He said, "I am here, but his mic does not work, but he can text in." Oh, he can text in. He's gonna answer it by texting it in. Let's do that. That'll work.
Okay, so is he ready? Dexter, are you ready?
He is ready.
Is the thickness of this coin?
So this coin, what is the thickness? $50,000, he says. $50,000
thick. I like it.
That's pretty. I think that is pretty darn close to the going rate of what that is right now, and how dense that coin is at this point.
If Lance is on the call right now, we would do the world according to Lance, and Lance would say that's a win. So we have a winner. So
that was my first choice. There was Lance, and unfortunately he couldn't make it today. So well done, Dexter. $50,000 thick. Yes, correct. Well done, sir.
So between Jason and myself, we'll get you a fabulous cash and/or prize. So thank you for participating there. So rolling over into the flexible pipe arena, what is an acceptable deflection there? And again, with our quiz there, you just went through that, but just to reiterate that, with APWA, for all ACPEs and polypropylenes, 5% max, corrugated metal at 7.5% maximum deflection. UDOT requires anything that is less than 5% is acceptable. Anything between 5 and 7.5% you would evaluate. Take a look at that and decide what to do. and then anything greater than 7.5% would be rejected. So, and there's some reasons for that. Coming from my corrugated experience, we deal with ring compression theory, and that is when the soil's pushing down on the top of the pipe, that force is being transferred through the wall down to the bottom of the pipe, and that's being pushed back. So if I'm pushing down on the top and the bedding soil is pushing up with its natural force, those sides want to push out, and the soils have to resist that wall wanting to push out. If we get to a situation where we start to deflect a lot, we end up with a situation where now you are really not dealing in ring compression anymore. You're dealing with an arch where the soil in those corners that would be at the bottom of the top arching portion would have to support that load, much as a bridge would, or footings would on a bridge or an arch culvert, something like that. So that's when you start to get that transition of design and really how it operates in the soil. Wait a minute. Some of you are saying cracks. You were talking about cracks. Can't we talk about cracks some more? Why is any crack acceptable? Well, cracks can be divided up into a couple of categories. We'll talk about functional first. Functional is, does the crack impede or influence the ability of that pipe to perform its function? Is the crack such that some of the material has been dislodged and is creating an obstruction in the flow? Is some of the material missing? You know, are we getting leakage through the pipe that may be affecting the backfill material? You know, we certainly don't want anything that's going to impede the function of the pipe, but those hairline cracks and the cracks that are within the specification that we've just discussed have been shown through specification and trial and testing that those cracks are not functionally a problem. The second thing you want to look at, is it a structural problem? We're going to look at a few examples here in a minute of potentially structural problems. Now have we gotten into the steel, or have we removed enough of a wall that now that pipe can't support itself as those forces are being transferred through the wall? So we really want to be able to look at a project and look at a pipe out in the field and determine, is this a loss of functionality? Is it a loss of structure? And then you're making a determination on whether you need to do anything at all, or if we need to get into some potential repair type of processes that we'll talk about here in just a moment. One of the things that maybe some of you know in this group, and maybe some of you don't, is that concrete has the ability to heal itself. One of its properties is called autogenous healing. It is one of the only pipe, in fact, it's the only pipe that I know of that has the ability, once installed in the ground, to actually heal some issues that it has, mainly with cracking. And depending on the crack size, we'll get into that a little bit. I don't want to spend a whole lot of time here, because this is a presentation in and of itself. There's a lot of chemistry and science to it that needs to be explained, and we're going to kind of gloss over that. But I'm going to give you some references here at the end if you have an interest that you can go look this up. But so it can heal itself. You have to have some moisture involved. If it's a dry pipe, you know, you're obviously not going to get that. But it will seal, crack, and protect reinforcing steel. Now you're going to give me this strange look. I know probably half of you are out there going, what? What's he talking about? But I just remember my first experience with this, and I didn't know what it was, as being a child and visiting my grandma. She lived up in Sugar House in an old home, and her basement was unfinished, and we'd go down and play in the basement. And she had all these white lines, you know, in the crack area in her foundation wall. And I always, what is that? Why would grandma come down and paint the cracks in the walls or whatever? And it wasn't until I started with Oldcastle and was introduced into Autogenous Healing that started to connect with me. This is a box that is up. If any of you enjoy the Star Valley area, if you ever go up to the Intermittent Springs, you hike right by this box and you've noticed it. It's a very old box, water vault that comes off the stream to supply the water down to the valley. And it's, you know, it's struggling. It's had a lot of years of abuse, and it's cracked through some forces over the decades that it's been here. But you'll notice a lot of this effervescence. This is autogenous healing, and we'll talk really quick through the science there. But this vault has cracked over time, and those cracks have actually healed themselves thanks to some of the environmental and internal conditions that exist. This was a pipe that we actually provided up here in Weber County that we put this is actually a fitting that we put on the pipe. So there's a manhole that goes up and out of here, and you have to, you have to put those two pieces together, and you have to put them together with grout, to get a manhole to stick on top of a pipe so that you have an access into the pipe. And we had it was very high groundwater. We installed these. We had water coming through some of that patch work where we were tying those two structures together. And we had even just pouring water coming out of this when it was first installed. Well, this is within about a week and a half of installing that, noticing these leaks. We came back in to see how it was coming, and you can see all of this effervescence and these stalactites coming down through the concrete. And this is actually, and we'll talk about it here in a second, this calcium carbonate that's being created with the water and the cementitious material. And you can see a very live version of that chemical reaction there, and the healing. You notice we don't have any running water here anymore. We have some damp spots, and within another couple of weeks, those damp spots even disappeared. So science behind it really quickly. Again, we're kind of running out of time, but free calcium oxide in the cement, in the cementitious material, and there are calcium hydroxides that are liberated as water is introduced, and that creates a hydration of the tricalcium silicate. Carbon dioxide that is in the air, inside the pipe, or the soils outside, or even the water that's going through the pipe, that's supplying carbon dioxide to this chemical reaction. So that's constantly being fed, and that through that process, that carbonates the calcium oxide and the calcium hydroxide and creates calcium carbonate crystals or limestone. And that's what we saw in the picture previously, is that calcium carbonate actually leaching out. It was filling that crack, but there was so much being produced, and the water was bringing so much of that out that it actually created that buildup outside the wall of the pipe that we saw. It seals those cracks. So if we ever want to, this is Jason's slide for all of his chemistry nerds out there. Whoop, whoop, everybody put your hands up. Calcium hydroxide, add carbon dioxide to it, we end up with calcium carbonate, and water is the outcome. So that's just for our chemistry folks out there. And again, we have a presentation. We have presentations that can explain this more in depth when if you have more time at some point and have some interest. This is actually a pipe that was put in. You see this crack all along the bottom of this concrete pipe. There's a whole nother presentation we can give on cracks and crack creation and why they're created. But this one, typically, when you see a crack on the inside and the invert of the pipe, means that there was an excess loading on top of the pipe. So you ended up with a crack in the invert of the pipe, and you end up with a crack really straight above it in the crown of the pipe. And then if you're able to look outside where the dirt backfill was, you'd find a crack at the spring lines on the outside of the pipe under this condition, where there's too much loading on that pipe, or they've driven heavy equipment over it without the right construction backfill over it. There's a couple of reasons why that happens, but you can see that water was introduced here, and you can see that chemical reaction is taking place, and we're getting calcium carbonate created in that crack and actually sealing that crack. You may ask, how long does it take? Well, we asked ourselves that here a couple of years ago when we, here at the Mountain States Concrete Pipe Association, we had some customer appreciation lunches in accordance and that coincided with the American Concrete Pipe Association Pipe Week. And both plants, the Geneva plant and the Oldcastle plant, we went out and we cracked some pipe on purpose. We put this in our deload machine, and we crushed that pipe until we opened up, and I can only speak for Oldcastle, we opened that pipe up to about 2/10 of an inch. And then when we took the pressure off, those cracks went back to about a 0.05. And then we stood them up. We cut that pipe in half, so we have two specimens, but we broke that pipe as one so that they had a relatively similar crack in both pieces. This near piece we put, and we filled that with water for 3 weeks prior to the luncheon that we had. It had an 0.05 crack in it. It was leaking at the same rate that this one we set up that day. So this is the other half of that pipe that we did not put water in it for 3 weeks. We let that run to show how bad the crack was leaking on day one when water was introduced to it. and this was leaking at about an inch a minute. And this one, after 3 weeks, when it started, it was about an inch a minute of water we were losing out of it. After 3 weeks, we were losing an inch of water out of this pipe in 2 hours. And within 2 months of having water, this was completely sealed off and it healed itself. And this was the, this was the new sample just to show how bad the leakage was through that similar crack. So it's very educational for us to do it. We know it existed, but we really wanted to run a time test and really see under certain situations where gap width and water to it, how that affected those. And we were very encouraged by the results and were able to prove proof of life concept for autogenous healing. So there are some conditions that affect that calcium formation. Obviously, we have to have moisture present. Water under high pressure, the higher the pressure, the longer the healing, if any. If your water pressure is too much and carrying too much water through there, it'll actually flush the calcium carbonate out. So, the water flow through that crack can be a factor. Crack width and shape, if it's a parallel crack where it's completely open, that will heal at a different rate than a V crack where it's kind of a hinged crack where it's touching at the bottom and open wider at the other surface or the top surface. The shape of the crack. Some of these things come into consideration when we talk about how long it takes to heal. Crack width, O100 will heal within days or months. If you get up into the O600, it can take up to years to fill that gap because there's a lot of space there to fill. If you want, I've listed some of the references that we have for that, some of the studies that have been performed, if anybody's interested in that. But if you're really interested, we'd love to come and talk to you about it, give you the presentation and kind of the long version of this. So really the question, I know there's several of you going, well, that crack, it's going to heal itself, but it's weaker there, right? And we actually found that not necessarily to be the case. We took that piece of pipe that healed itself, put it back in our deload machine, and this deload machine just basically crushes this pipe. And actually the cracking, and we tried to orient it in the same orientation that we had in before, it actually cracked in a different location, did not crack our healed portion. So again, that crack can actually come back stronger than its original form. So when we're talking about repair options for cracks, if we find some cracks like this, a 1/100th inch crack, there's no need to repair that. Larger cracks, you have some options like injection grouting in those situations, or you can put an internal or external grout sleeve. There are internal sleeves that will do a localized patch over cracks, or you can go out and pour a concrete collar on the outside, or you can actually come in situ form or run a liner through it to cover over those cracks in those situations. If it's worse than that, you've got a big structural situation, obviously remove and replace is sometimes that option. Let's move on to inspection. Why do we need to do post-inspection? The benefits, to ensure the pipe meets the standards. You guys spend a lot of time trying to develop standards, and you know what you want, and you're trying to get what you want out of that system. Document, if you do a good pre-installation or installation, then post-installation, it actually will document the variation between the installation date and the period you test it, whether it be at 30 days or a year, depending on how you write that in your specifications. But you'll be able to see if anything's happened, if any of the bedding is settled, or if there is any deflection that happens over time that will give you a good idea of what future performance may be. You're still within your warranty period. I greatly encourage you to do post inspections to identify any future issues or issues that you may have had with installation. It protects your investment. You guys are guardians of public trust, and it really helps protect what you wanted to put in your system. And accountability helps you keep your installers accountable and making sure that they're installing them as per specifications that are required, either by yourself or by the national specifications. So post-installation inspection is not meant to replace inspection during installation. Nancy Pelosi has driven that point home millions of times. I'm amazed that all of us haven't really heard that message, but it's true. And I don't even hear Jason laughing.
I'm laughing because I know what picture I had when I sent you the presentation, and you
I know.
swapped it out. So that's funny. I like that.
I did that for you, Jason.
I like that. You swapped one angry conservative for an angry liberal. I like it.
Well, we got to do what we got to do. The one nice thing about post-installation, I know there's concerns, especially on the inspection side, that we don't have the time or money to go out and have an inspector at every job site all the time, especially with as busy as construction is right now. I get that's a real burden and an issue to make happen all the time. So it's tough to be out there all the time, make sure it's all happening right. But when you do a post-installation inspection, most of the time you can actually put that in the contract. It can be a bid line item. It's part of the bid where that money is covered in the project, but it's also requiring now we get a third party in there that inspects everything for you. And it creates that little bit of insurance that you at least know that those got inspected, you know what condition they were once you did that post inspection, and you can identify any problems, and if you've got to have the contractors go back out and fix anything, you can. But that's where that mechanism of we don't always have the money or the personnel on the front end. We can require it on the back end, and there are plenty of companies out there that can help with that post installation inspection.
Hey Jeff, before we jump into the methods, I'm curious to see. I've got one last poll question. I just want to see what percentage of projects are enforcing post-installation inspection. And I don't mean like what percentage of your pipes are you checking. I'm just saying with projects that you're involved in, what percentage of those projects are doing any amount of post-installation inspection, whether that's mandrel for flexible, video for concrete, video and mandrel for flexible. If they're checking any pipes at all, I want to know what percentage. So I'm going to launch that right now. And so what percentage of projects that you're involved with currently are you enforcing PII or have that written into the spec? 0%, 25%, 50%, 75%, 100%. And I know sometimes if you're with like a city, if you have that, written into your spec and you do 100% of your projects PII, great, that's awesome. If you're not, then we can take a look at that and help you. We've helped cities in the past that were having issues with poor installation, and once they started enforcing PII, we noticed, oh, what do you know? Installation gets better. Interesting. So we'll give it here about.
While we're buttoning that up, I do have to apologize to everyone here that's present because it is nearly lunchtime, and I apologize for throwing angry Nancy Pelosi pictures out when everyone's trying to have their lunch. So I really do feel bad about that.
I mean, yeah, you don't want people to lose their appetite. That was pretty uncouth, Jeff.
Well,
all right, we'll go ahead and close this here. Pretty interesting results, different from the one that we did a year ago. Let me share those. 33%, so about a third of the people here are saying 100% of their projects are using PII and enforcing PII. About a quarter of the group said 50%, 20% or so said 25%, and 20% and one fifth of the people are saying that none of their projects are doing any PII. So that's interesting to know. If you do have any questions, please reach out to us. If you're in that 0% and you would like to see how we've written it into other cities and help those cities have better installations and what that cost is, feel free to reach out to us. We'd be happy to answer that question for you. So go ahead, Jeff. You can move on with methods. Great job,
Jason. Thank you. No, it's good. So options, there's obviously a number of options, especially for concrete. We're always talking about closed circuit TV, and with flexible pipes, closed circuit TV will tell you a lot, as well as pulling a mandrel will tell you a great deal. Because it's very hard to look down a pipe, and I was looking for a pipe picture earlier that really was demonstrative of this. When you look down a pipe, if it's not grossly deflected, it's hard to tell. It's hard to see 3 or 5% deflection. It still looks round, but that mandrel that you pull through that pipe will definitely give you the go, no go, and it will tell you really quickly if the deflection's beyond specification. So on the closed circuit TV recommendations, when you're running a camera down there to inspect, please make sure and have written into your specs that they are NASCO certified. Jason Allen is actually NASCO certified. Ralph with our company and Randy were NASCO certified. We sent them down primarily just so that they could watch the inspectors and make sure the inspectors were, when they were on our projects, that they were performing those accurately and correctly, and definitely some things that you need to watch for as you're doing a closed circuit TV inspection. They need to go slow enough to see issues. We've seen videos, and maybe some of you in the group have seen videos where, you know, they're either going too fast, or they blow over something that you see that they didn't see and look at. So make sure they're going slow enough to see the issues, and that they actually do look at all those issues that are there. NASCO recommends that you go no faster than 30 feet per minute. I've seen some where they ripped through there so fast you couldn't see a crack or an issue if you had to. It was just, you know, it was just very fast. So make sure they're doing it right. Make sure they stop and document cracks and damage. All damage. It's a lot easier to burn up, you know, file size than it is to not see those things and identify them. So make sure that they're identifying, documenting all those things. Full circumferential viewing at the joints, and make sure it's perpendicular. I've seen some videos where a guy will stop, you know, an inch back behind the joint and do a circumferential, and you don't really see down the joint. You want to be able to see down the joint, see if there's any damage in the bell area, or if there's any rolled gasket. You know, some of those things are identified. So you want to have a good clean shot down the joint and go all the way around the joint to identify issues. APWA says zoom where necessary. Definitely zoom in where necessary when you find some issues. Any bit of information that you can get out of that camera will be beneficial into deciding what you need to do with issues. For concrete pipe, what are we looking for? We're looking for cracks. We're looking for joint gaps. We're looking for gaskets showing, whether a gasket is rolled. We're looking for damage in the pipe, whether it's got some chips or chunks out of it. You're looking for obstructions really in the flow of your pipe. Is there a lot of gravel and things that have built up through construction? And then misalignment, if you got any bellies or snakes, have they aligned the pipe right in their installation? So we'll just look at a couple of examples really quick. We only have about 6 minutes left. Here's a pipe where we did need to get perpendicular, see down that joint, and we see that gasket is rolled. That's going to create an issue. You know, there's an area there that gasket is not sealing in that pipe. Looking at this one, you know, it's a fairly good shot down there, but looking at the crack, being able to identify the crack, if we had a good 360 view of this, we'd see what kind of damage this crack has, if this is actually a loose piece of concrete. Here again, another chunk. This one looks like at some point that's probably a complete chunk. Usually when you get some offsetting where those two are not sitting at the same level, you've got a piece of concrete pipe that the crack is obviously bigger than an O100s, and you know, you may have some, if you've got some shifting of those plates, then you know you may have a structural problem that you may have to address there. And then this one, definitely a big structure where we've got the gasket coming through. There's obviously nothing holding it. They've broken the spigot, but then we also start to see the wire. Now this is really into some damage that's really got to be looked at and really taken seriously as to whether we're going to take out and replace, or we're going to pour a collar around it. You know, definitely these types of situations would need to be addressed. And again, as Jason was always saying, Mountain States is always more than happy to help analyze these, look at them, and give you know, give our thoughts about what's happening here. So, and then going back to that crack in that pipe that Randy's card was by, it's hard to tell how big these cracks are. This is a very zoomed in picture. How big is that crack? We don't know. There are actually CCTVs out there that have lasers that sometimes they point a laser there, and the width of the laser light is known, so you can measure that against that crack to see how big it is. But you just have to be careful when they do zoom in. It makes things look much bigger than they really are. So things are always larger than they may appear. So be careful of that when you're analyzing videos, that you don't jump the gun and think something is a bigger problem than it is. It may take another look and analysis. So things to remember: repairs are possible, can be costly, but in almost all cases they can be handled. Mountain States, you know, we're always a good resource to call and see and get our opinion, our help. And we're as invested in this as the rest of the community, everybody on this call. We want good installations. We don't want problems with our pipes. We love it when a project comes together and it's put together right. Things to look for in flexible pipe: deflection, cracking, rib growth, joint gaps, damage, some of the same things we're seeing in concrete pipe, obstructions in the pipe, sags, bellies, anywhere where they had misalignment. Flexible pipes are a little more sensitive to contour in the trench, so you may find some irregularities in alignment. And then non-elliptical deflection, and that's what this picture is. Kind of a really good story about they're coming up in their lifts, but they may have over compacted one side or put lifts up one side before they got to the other side. Will kind of create some of these issues. You know, loading over the top. This picture here, this is the same story in concrete pipe. You know, they obviously had something come in, had a point load here and poked right through the pipe, but you'll have the same issue with concrete pipe. You'll notice if we end up with a large boulder that came out and that gets put back in, and that boulder lands right on top of the concrete pipe, and it creates a point load situation where the loading and all of the live and dead loads are sitting on top of that rock, creates that point load, and you'll see actually a spider crack in concrete pipe. And there's a whole nother presentation that we would love to come and give you, is about, you know, crack types and what causes the different types, so that as you're inspecting these, there's ways of figuring out kind of what's happened without digging that pipe up in most cases. So, you know, point loading. One thing about flexible pipe is much easier to see installation variances. Any variations in installation, it can tell the story very quickly. Mandrel, I won't spend a whole lot of time on the mandrel, but the 9-fin mandrel, these are generally made to the OD less the 5% or whatever your allowable is, and then you just take it down, you tie a rope to each side, and then you pull that through by hand, and if it gets stuck in a deflected area, you know you have a greater than allowable deflection in that pipe area. Lasers became pretty in vogue, but they're very expensive. In this situation, you can see the green line represents what the round shape would be, and then the laser shows you what the pipe is, the actual is, and you can start to see that deflection. The nice thing about the laser is going to pick up that 3 to 5 to 7 to 10% deflection that you may not see with the naked eye, especially on larger pipes. So really, really good. It's hooked to a computer program that will spit out exactly how far it is deflected. Really good system, but again, it's going to be pricey, and hopefully that becomes more prevalent and the prices start to come down, because that's probably your best weapon in doing some installation checks. So just in closing, I don't know that we really have takeaways, but really, you know, making sure that things are installed correctly, making sure your specs are identifying the differences between a rigid and a flexible pipe installation. Make sure our inspectors understand the differences and what to watch for, and then definitely making sure we have post-inspection so that we see that our installed product is what we actually asked to be delivered to us, and identify any problems and take care of those before you know, becomes a real problem. So appreciate everybody's time. I'll flash Jason's information up here if you need to get a hold of Mountain States Concrete Pipe Association. If you have any questions about this, if you want some, you know, additional presentations on any of the topics that we kind of tangentially referenced here, we'd love to come and talk to you about really about anything in the industry. And appreciate your time, and everybody have a fantastic day.
Thank you, Jeff. I appreciate it. If there are any questions that you have, feel free to shoot them our way. We'll stick around for a couple more minutes and answer any questions. It looks like I just got one question on whether they could get a copy of this presentation. Yes, I'm more than happy to share any of my presentations with anybody. I can get that to you. Here's my email address right there on the page there that's on your view. Write that down. Shoot me an email, Rebecca, and I'm happy to get that. Now, we also do have this. I record these, so I make them available with the video itself, so you can watch the video again of the presentation, or I can send you the PowerPoint. That either one will work. Just let me know what you want, and I can get that over to you. Not a problem. If there's any other questions, you can type those in now. Feverishly typing and wondering so many pressing things and questions that you have. Looks like we have, I think that's it. Looks like those are all the questions, Jeff. So you did such a good job clarifying everything. I don't think there's any questions.
I love it.
So Okay. Well, perfect. Well, if you do have any questions, feel free to email those to me or to Jeff. We're more than happy to answer those questions that you have about this stuff. But yeah, thanks again, Jeff. I appreciate it. It was a great job. Whoever put this presentation together did a phenomenal job. It was very exciting and amazing. And so I just think they should get so much credit for helping you put all the slides together and things. They did a great job.
Good. Jason did a great job of giving me the presentation.
Oh, that's right. Yeah, it was me. Oh,
that I doctored and put some Democrats in. So
yeah. No, I appreciate that. It's what would we do without differing political views in
That's
this
right.
world? So, well, thanks everybody. We appreciate it. This will be available to watch on demand on our website. So I'll get that loaded this afternoon. I'll be sending out a PDH for this to everybody that was on the call. So you should be seeing that also this afternoon or tomorrow morning at the latest. So keep an eye out for that. If you don't receive one, please reach out to me. I had someone whose email did not get added to that list for whatever reason, and so they didn't get a PDH one time. So if that happens, reach out. I'm happy to help you out. Don't hesitate to give me a call or an email. So thanks again, Jeff. Appreciate it. We want to thank Heather. She had to run, but thanks, Heather, for being on the line and answer some questions when we put her on the spot. And we'll look forward to seeing everybody soon and talking to everyone next month for our next month's presentation about engineering ethics and liability.
thank you, Jim. Appreciate it.
Hey, thanks, Jeff.